All right, measuring angles. By definition, an angle is formed by two rays with the same endpoint. An angle is formed by two rays that share an endpoint. The little symbol in the parentheses behind the word angle, that's your symbol for angle. It's like we put a bar over segments and a bar with two arrows for line, and one arrow is ray. That's our symbol for angle. Naming the angle there I have at the right, there are 4 different names you could give it. I think one of them is already on your paper. They give you angle TBQ, right? Okay. Another name, angle QBT. I can go the other way around. When you use 3 letters, you have to make sure that the vertex, that's that endpoint that they share, is in the middle. When you name an angle with 3 letters, the vertex always has to be in the middle. You can use 1 letter to name an angle, and you have to use the vertex angle. So I could also name this angle B. And the 4th name would be angle 1, that number that's inside of it. If there's no degree symbol after it, then it's talking about the angle, not how much it is. Sometimes you'll see your angle symbols that have a line through it, like I did on angle 1. That's so you don't confuse it as the less than symbol, so you wouldn't think less than 1. I'm talking about angle 1. So you can write them both ways. Most of the time, you're going to want to use 3 letters. And that's how they'll have it in the book. In your worksheets, they're going to name with 3 letters. It's either 1 letter or 3 letters. Can't name an angle with 2 letters. 1 or 3. This isn't on your paper. Just a little discussion here. Should you name angle ABC, ABC, that would be this huge one, as angle B? Why not, Caitlin? Excellent. Could I name angle ABC as angle 1? Okay, let me say it again. Can I name angle ABC as angle 1? Oh, no, ABC. No, that wouldn't make much sense, would it? Would it make sense to name angle ABC angle 2? No, definitely not. The last 2 hopefully make more sense than maybe the first one. I wouldn't name angle ABC angle 1 because this is only part of that entire angle. And same with angle 2. Angle B, I don't know if you guys heard Caitlin's explanation, you wouldn't want to name angle ABC, this whole thing, angle B. Because angle 1 is also using this as a vertex, and so is angle 2. So when I say aloud angle B, Julia, what angle do you think I'm thinking of? Dang it, I was. What about now? Which one when I say angle B? Nope, angle ABC, the big one. Did you see how I said 3 on that? Okay, thanks. Okay, when you only have 1 angle at the vertex, like right here, then you can use 1 letter. But if you have more than 1 angle at a vertex, then you have to use 3. Capiche? Kaposh, awesome. This should be a review. Let me get out my popsicle sticks. Barbie, an acute angle has an angle measure of what? Yes, less than 90 degrees. I'm over where all the words are at, like below those 4 pictures, I'm to all the lines. An acute angle has less than 90 degrees. Sorry, I don't know why I have the word has there. Right angles. Hang on. Nathan, what's a right angle? Yes, sir. I'm just going to say it equals 90 degrees. These are my short note-taking skills of writing the vocab words down. If you want to get the whole line sentence definition, you can look that up in the book. Right angles, I mean, we're most familiar with them probably in a square. We have a symbol for a right angle. If they put a little backward 7 in there to make a square, that means it's 90 degrees. So instead of writing the number 90, they'll just put that backward 7 and complete the little square here in the corner. That means 90 degrees. Barbie, what about an obtuse angle? More than 90 degrees? But what? Excellent, but less than 180. You could write between 90 and 180 if you want. Obtuse angles have to be bigger than 90, but less than 180. Nathan, what about a straight angle? Excellent. Straight angles equal 180 degrees. Acute, less than 90. Right equals 90. Obtuse, between 90 and 180. And a straight angle equals 180. It's a straight line. Cool. Last week, congruent segments. What does that mean? Yeah, like the same. Good. What about congruent angles, Cole?
They're the same.
Same how?
Measure.
Good. Same angle measure. Good. Congruent angles have the same angle measure. Angles of the same measure. Or same degree, if you want to write that word instead. Congruent angles are angles of the same measure. So if I have an 82-degree angle over here and an 82-degree angle over here, those are congruent angles. They have the same measurement. Cole, do you remember how we marked congruent segments last week? Well, that's the symbolism. But how about like in a picture? Do you remember what we did to these segments to show that they were congruent? Don't remember? Does anyone remember? Trinity? Yeah, like 1 hash mark or 2 hash marks. Good. Remember that now, Cole? Good. There's symbols for angles to mark them congruent. We use curves. Those guys are congruent because they have 1 curve. Those 2 are congruent because they both have 2 curves. So the number of curves that line up with them, that marks your congruent angles. Sometimes, just depending on what we're using, they put little hash marks within the curves. Still means they're congruent. You would just match up the hash marks then. Cool. Congruent angles equal measure. Now I'm to the pictures that are back towards the top. That first picture, Stiliason, what kind of angle would you say that is? And it has to be between 0 and what? Good. The second one, Trinity. This one, what would you say that is? Which means it has to equal. Trinity, how about the third one? And it has to be between which 2 angle measures? Stiliason, how about the last one? Good. And what is the measurement for a straight angle? Straight angle still has a vertex. It's actually formed by opposite rays. Because shear and endpoint form a line, opposite rays. Example 1. You're going to have to fix yours. Well, just add to it. Put a number 3 in the interior of that angle for me. And then go ahead and name that angle 4 different ways. Got a name for me? Got another one? Got another one? Got another one? Excellent. Angle BOC, angle COB. When you use 3 letters, put the vertex in the middle. Since there's only 1 angle at that vertex, then we can use the vertex and call it angle O, and then angle 3. Nice. Don't forget your angle symbol in front of each of those, because if you just put O, then it looks like a point. If you just put COB, then you might be talking about a packer. We don't know, though. Anyone? No? Thanks, Marcel. All right. Number 2, I'll give you 20 seconds. Mitchell, how would you classify this one? How about the one in the middle? How about the third one? Good. When you classify, that's when you pick from those 4. Acute, obtuse, right, or straight. When you name it, that's when you take letter combinations and give it a name. Just like we put letters together to come up with the name Riley, but I'd classify her as a female. Okay, so make sure you read carefully when you're doing that in your homework. Difference between classifying and naming. Angle addition postulate. If we have point B in the interior of angle AOC, what's interior mean? Inside, good. So angle AOC, point B is inside of it. Then the measure of some angle plus the measure of another angle is going to equal the measure of angle AOC. Brad, which 2 angles do I have to get add together to get angle AOC? Sweet. You said BOC, right? Good job. Angle addition postulate. The measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. Two parts make a whole. This next little sentence, this is kind of like a sub-postulate to this one. Says if angle AOC is a straight angle, then the measure of angle AOB plus the measure of angle BOC should equal what? It's a straight angle. 180, good. Not that I don't agree that it would equal AOC, but since they're telling us AOC is a straight angle, then we automatically know they have to add up to 180. We can figure that out because they told us it was a straight angle. So on your worksheet Thursday, maybe it's next week, when this sentence is written there, put 180 on it. Okay. Example at the bottom, using your angle addition postulate. Suppose that the measure of angle 1 is 42, and the measure of angle ABC is 88 degrees. They want us to find the measure of angle 2. Angle 1 is 42, ABC is 88, and we're supposed to find angle 2. Grant, can you help us out? Excellent. We know what the entire thing is, and part of it is 42, and they want us to find the other part. So if we're trying to find a part, you said subtract, right? So the measurement of angle 2, 46 degrees. Math notation, when you're going to say the measure of an angle equals some value, you should put the little m there. Measure of angle 2 equals 46 degrees. The measure of angle 1 is 42. The measure of angle ABC is 88. Anytime you're giving me the angle measure, then put the little m in front. Cool, we're cruising. The next 4 terms are going to represent angle pairs. How many are in a pair? 2, right? So these come in 2s, not 3s or 4s or 1s. There has to be 2 of them to have these. Vertical angles, 2 angles whose sides are opposite rays. And it tells us to look for intersecting lines. Opposite ray, share an endpoint, form a line. So those blue ones, those are opposite rays. Opposite rays, share an endpoint, form a line. The red ones are opposite rays. Angle 1 is formed by a red ray and a blue ray. Angle 4 is formed by the red opposite ray and the blue opposite ray. So angle 1 and angle 4 would be a pair of vertical angles because they're formed by opposite rays. They're formed by those intersecting lines. Same thing here with 2. 2 is formed by red and blue dotted. And 3 is formed by, well, the rest of blue and then red dotted. So 2 and 3 are another pair of vertical angles. Vertical doesn't necessarily mean up and down. It kind of means that they're across from each other. If you didn't mark them, list which pairs are vertical angles. 1 and 4, 2 and 3. And your helpful hint is to look for intersecting lines. Where you have lines intersecting, you should have vertical angles. Because opposite rays form lines, therefore we should have vertical angles. Adjacent angles, 2 angles with a common side, a common vertex, and no common interior points. Adjacent means next to. Adjacent angles are going to be next to each other. When it says this, they have a common side and a common vertex, that means they share a ray. Common side, common vertex, they share a ray. No common interior points. That's referring to the idea that they're not going to overlap each other. Adjacent angles are next to, share a ray, they don't overlap. If you're vertical, you can't be adjacent. If you're adjacent angles, you can't be vertical. You're one or the other. Or you can have a third one where you're neither of those, but you can't be both. Angle 3 is adjacent to angle 4. They're next to each other. They share this ray, and they don't overlap. Overlapping, that would look something like this. So angle 4 is this bottom one, and angle 6 is the whole thing. They would both share this ray, but they overlap each other, so they're not adjacent. They're non-adjacent angles. They can't overlap. They just have to be right next to each other. Okay. Vertical. Across from each other, they're formed by intersecting lines. Adjacent angles are next to each other. I have 7 angles up there. Brooke, from my little diagram I just drew, give me a pair of adjacent angles. We say what? Adjacent. What's adjacent mean? Okay, are 1 and 4 next to each other? 1 and 2. Excellent. Ross, give me another pair of adjacent angles. Yes. Logan, give me another pair of adjacent angles on the smart board. Already got that one. Excellent. Lexi, give me another pair of adjacent angles. Did someone say that? Oh, that would work. Those are adjacent. Good. Anna, can you give me a pair of vertical angles in the diagram? Yes. Good job. Haley, what's the other pair of vertical angles? Yes. Good job. If you can't find the vertical angles right now, that's okay. Just keep practicing, because once you start to find them, they really stick out. 2 and 6, that's what you said, Anna, right? If I look at the intersecting lines for 2 and 6, you can see that they're both using blue and purple, blue and purple. Haley, you said 1 and 5, right? Those ones are using blue and yellow, blue and yellow. I don't have any other intersecting lines, so maybe on like worksheets and notes, if you highlight all the lines different colors, whichever ones are between them, those are your vertical ones. Vertical angles. If you can't find them, start looking for them, because they are the best ones ever. I was going to say the awesomest, but that's not a word. Complementary angles. 2 angles that have a sum of 90. Nathan, Pop, when you hear sum, what math do you think of? Good. So complementary angles, 2 angles that add up to 90. It has to be 2. It can't be 3. It can't be 30, 30, 30. Complementary comes in pairs, so there's only 2 of them. Supplementary angles, 2 angles that have a sum of 180. Nathan, Pop, when you hear sum, what do you think of? Good. So supplementary are 2 angles that add up to 180. Again, only 2. Can't be 60, 60, and 60, because that's 3 angles that add up to 180. These come in pairs. Here's a link. Complementary angles make a corner. Complementary corner. Remember, corners, if we construct them correctly, will have a 90-degree angle. Complementary corner, add up to 90. See that alliteration? Complementary corner. Okay. Supplementary angles form a straight line. Supplementary straight. Straight lines have 180 degrees. Complementary corner, 90. Supplementary straight line, 180. Only can be 2 angles that add up to 90 or 180. In this first little picture of my complementary ones, they form the 90-degree angle. These would be adjacent complementary angles, because 1 and 2 share this ray. So these would be adjacent complementary angles. This one, obviously 40 plus 50 is 90, so they're complementary. We would just say that they're non-adjacent complementary angles, because they're not next to each other. They don't share anything. So you can have adjacent complementary, And you can have non-adjacent complementary. Same with supplementary angles. 3 and 4, these are adjacent. They share this ray, they form a straight line, so they add up to 180. So I would say these are adjacent supplementary angles. 75, 105, that adds up to 180, but they don't share anything, they're not adjacent. So we would just say these are non-adjacent supplementary angles. So you can have both, adjacent and non-adjacent. Supplementary, straight line, 180. Complementary, corner, 90. Cool. Now we're all going to just do examples here. So number 4, in the diagram, identify pairs of numbered angles that are related as follows. So part A, we have to find a pair of complementary angles in that picture. Gavin, pair of complementary angles in the picture? Yes, sir. Good job. Angle 4 and angle 3 would be a pair of complementary. Gavin, would you say they're adjacent or non-adjacent? Sweet. Caitlin, part B, a pair of supplementary angles? Would you say those are adjacent or non-adjacent? Good. Are there any other supplementary angles, Caitlin? Are you sure? Excellent. 1 and 2 and 2 and 3 are supplementary angles. They form straight lines. They add up to 180. Morgan, how about vertical? Yes, angle 1 and angle 3. Vertical across from each other. They only share an end point. Ruth, how about a pair of adjacent angles for part D? Gavin, how about a different pair of adjacent angles? Ruth, how about a different pair? Gavin, how about another pair? Ruth, how about the last one? Excellent. Good job, guys. Adjacent next to share array. Number 5, making conclusions from a diagram. So based off what's given to us, how they draw the picture and how they mark it, we're going to decide if these statements would be true or false, or if we can conclude it. Cole, Siegfried, what do those things mean again? What do these things mean? Good, that they're congruent. Only one's dealing with segments and the other one is dealing with what? Yes, good. So for part A, they want us to decide if angle A is congruent to angle ACB. Cole Siegfried, is that true? Is angle A congruent to angle ACB? How did you know that? Because it was marked, right? In parentheses here, I'm just writing it was marked. Some days soon, in the next couple weeks, you're going to have to explain why it's true or false. And sometimes your explanation is as easy as saying, well, it was marked for me, that's how I knew they were congruent. Or it was marked 90 degrees, that's how I knew. Hunter, part B, angle B and angle ACD, supplementary. That's what I have marked in red up here, and those are the two angles that we want to know if they're supplementary or not. Why not? Excellent. Good job. Nope, these wouldn't be supplementary. We don't know the angle measures for them, and they don't form a straight line. They don't form a line. In order for the angles to form a line, they need to be adjacent angles. These ones are non-adjacent. Cole Siegfried, part C. The measure of angle BCA, so that's this one here, and the measure of DCA, so that would be this one, equals 180. Do you think this angle plus this angle would add up to 180? So which one do you want to go with? Yes, good. Why would you say that? Why'd you change your mind after I went back over it? Yes, you do. What do they make? Yes, they're adjacent and they form a line. So they have to add up to 180 because they make that straight line. Hunter, the last one. AB congruent to BC. True? Yes. Can I conclude that? The segment AB is congruent to segment BC? Why? Exactly, because they marked it for us. Easy explanation when they just give you the markings already. We have a little bit more. Number 6, using the diagram at the right, you're supposed to part A, name angle CED 2 other ways, and then answer part B. Julia, what did you get for 2 other names for angle CED? And? Excellent. Julia, would it be correct of us to name any of our angles angle E? Why not? Good. I'm just going to say no multiple angles with vertex E. Does that work for you? Okay. Multiple angles with vertex E. Or however you answered it. Maybe you said there's more than one angle at that vertex, or it's too confusing. There's too many angles there. I'm skipping 7. Number 8. If the measure of angle DEG is 145, we're supposed to find the measure of angle GEF. Nicole, how can I find the measure of angle GEF? Where did you come up with 180? Good. These 2 angles are adjacent and form a straight line, so together they have to add up to 180. So I'm supposed to add those or subtract them? What'd you say? Good. 180 minus 145. The measure of angle GEF would be 35 degrees then. This is your angle addition postulate, even though you're subtracting. But without that, then we wouldn't have our subtraction rule either. We got to do this one. Number 9, it says name an angle or angles in the diagram that are supplementary to each of the following. Peyton, number 9. We're supposed to find a supplementary angle to angle DOA. So that's DOA. We have to find its supplement. What does it mean to be supplementary again? Yeah, which means they have to form a what? Okay, so we have to find another angle with this one that's going to make a straight line. It's going to complete the line. Yes, good job, angle AOB. Angle AOB and DOA would be supplementary. They form that straight line. EOB. Same idea with this one. Grace Wilford, find a supplement to angle EOB. Louder. Oh, sorry. EOD. Good. Any other ones? Grace? Is there another supplement to this angle? What is it? Good. BOC would also be supplementary to it. Sometimes there's more than one supplement there. You got to look for those straight lines. Killer. Number 11, very bottom. It says give the complementary and supplementary measure to each angle. So for part A, the angle is 30 degrees. I'm supposed to find its complement and its supplement. Jackson, complementary angles. Good, and supplementary angles. So if the angle is 30, Jackson, how am I going to find its complement? And what do I get? Good. And if the angle is 30, how are we going to find its supplement? And what do I get? Good. Give you like 37 seconds to do the next three. Taylor, what'd you get for the complement of 42 degrees? What about its supplement? Good. Lex, what'd you get for the complement of 95 degrees? Excellent. There is no complement to 95 degrees because I'm already over 90. Sometime in your future you will use negative angle measures, but not this year. What about its supplement? 85. Good job, Lex. Jackson, complement of 150. Good. How about its supplement? Good. So they all should have supplements, unless it's a straight angle, but you won't always have complements if it's obtuse. Questions? Cool. You guys rock.